We finally reached a point with logarithms where we can use them to solve exponentials when the bases on both sides of the equation are different. Up to this point, exponentials, we've been trying to get the bases to be the same. Now we can use logs to help us solve those problems when the bases are different. So our objective is to be able to solve exponential equations when the bases are different using logarithms. So let's start here. First idea is when the exponential bases are different, take the log of both sides. Now you could use either log, any log that you want to, but the recommendation here is that you use the common log. You could use natural log, but common log is just as good and oftentimes a little more familiar. So when we do this, I'm going to solve this equation. We've been able to solve this equation using the converting to logarithms. So let me show you that process, and then I want to show you a new method and then use it to apply to other problems. So this first one, if I were to solve this just by converting it into a log, you start with log base 8 of 17 is equal to x. Now we can use our change of base theorem. Log of 17 over log of 8 is equal to x. And when we do that on our calculator, log of 17, so we'll do log of 17 divided by log of 8, and we get an answer of 1.36. We'll round to 2 decimal places on this, so 1.36. So x is approximately 1.36 for this answer. Now let's do that same process and let's go ahead and find it using a different method. I'm going to look at this log, this exponential. I'm going to take the log of both sides. So I'm going to do log of 8 to the x equals log of 17. And remember, we've got properties of logarithms that we can now apply. The properties, one of them tells us that if we have an exponent inside of the logarithm, we can bring that exponent in front. So I'm going to bring that x in front of the log of 8 equals log of 17. Now remember, the log of 8 stays together, the log of 17 stays together. So if I want to divide, I'm going to divide by the log of 8, not by the log separately or 8 separately. They stick together. So I'm going to divide both sides by the log of 8. And notice then, what I've got is this statement right here. Log of 17 over log of 8. So I get x is equal to the log of 17 over the log of 8, which is approximately, as we did here before, 1.36 for an answer. So the second method here, even though this is easier to do in this case where you only have one exponent here, it shows you that we do now have another alternative, and will help in a problem like this where you have two different bases and now you've got variables in both exponents. So there are situations like this that will want to use this new technique to help us solve the problem. So my first step here is I'm going to take the log of both sides. I'm going to use my rule of the property of logs that says I can bring that exponent down in front. I'm going to take it down in front as a parentheses because it's the entire exponent multiplied by the log of 2. I have x times log of 3 here, bring that exponent down in front. Now I'm going to do an approximation of log of 2 here. So let's go here on my calculator and do log of 2 and get a decimal for that. So my decimal, I'm going to put it out to several decimal places past where I want to round my final answer. That's to allow the rounding to affect my final answer and not change the answer. So I'm going to go to 4 decimal places here, 0.3010. So this is going to be x plus 4 times 0.3040, 4 decimal places. Now let's do log of 3 here. Oh, sorry, 0.3010. So let's change that. 3010. Now let's do the log of 3 over here. So I'm going to do log of 3, and I get that one to be 0.4771. Okay, now I'm going to distribute this through. So I'm going to have 0.3010x plus 4 times that. Let's go ahead and distribute that and multiply. So 4 times 0.3010, and I get, when I multiply those together, I get 1.204. Now you have to deal with decimals, so this one's going to be 0.4771 times x. Now I want to bring the x terms together. So I'm going to subtract this term, which has a decimal in front of it, just the same as other numbers. So I'm going to subtract 0.3010x from both sides, 0.3010x. And so on this side, I'm going to have just the 1.204. And over here, I'm going to subtract those. So let's do 0.4771 minus 0.3010, and so what I get is 0.1761x. So notice it's just like subtracting, but now with decimals. And then I'll just do the typical thing of dividing both sides by 0.17, dividing by 0.1761, divide this side by 0.1761. And so when I do that, let's do that on my calculator. So 1.204 divided by 0.1761. Now we've done some rounding, so this will be an approximation. We get about 6.84. So my x answer is about 6.84 for this problem. So when we do these problems, you want to remember that the new technique is when you have different bases on the two sides and you've got exponents that include variables, you can take the log of both sides. That will bring the exponent out using this property that we have of logs. Then you got to deal with the decimals, but you can work with the decimals to solve the equation and find your answer with problems that we weren't able to do before.